So welcome everyone to the broadcast or the webinar joining us today. And thank you for joining us today for this really insightful topic discussing on your journey to so I see there are still some attendees, and we'll kick off now and we'll start, and the late attendees will be able to join in as well. Joining hosted by Baker Baines, and where we talk about your journey to Industry 4.0. So really interesting topics that we're going to be covering today. I'm agenda very quickly, just to run through it. This open and welcome done by myself, Daneel. I'm the Key Accounts Manager for Process, Plant and Manufacturing at Baker Baines. So I'll be taking you through the open and welcome, followed by Revolution, where I'll be handing over to my colleague Heilandi, who is the Process, Plant and Manufacturing Specialist at Baker Baines, which will give us some really insightful information to Industry 4.0 and to getting you to Industry 4.0. We're very fortunate a customer spotlight, Dabma Manufacturing, which I'll be introducing to you on the webinar, and we've got some closing and key takeaways, and we've got a question and answer session just after. So without further ado, let's start. So at Baker Baines, we believe in at Baker Baines, we believe in helping our solve their problems through digital transformation, helping them design and make a better world. So how do we do this? Baker Baines has evolved over the past 5 years from being an Autodesk reseller to a consulting company set out to solve our customers' problems through this digital transformation. In doing so, we offer various business consulting and improvements services to our customer, namely surveying and design, hardware and consulting, design software consulting, topped off with a blended learning approach, which we believe our customers can or should digest information more easily. Now, just looking further to that, you'll find that Baker Baines is an Autodesk Service Provider Select, which means that all of your consulting work that we would do for you, or any consulting work that's required, has been selected or approved, you can call it that, by Autodesk for that. Moving on to that, from some of the technologies that we serve or support, and to BIM services side of it is the TopCon Leica products. We are the second largest Autodesk partner in South Africa, so we're a gold partner as well. We've also supported different like the civil infrastructure industry with products like IDES. And to top it all, we support a blended learning approach, which is classroom for as well as online. And we're proud to be the sole distributors of a e-learning and the industries that we serve are just not one. We serve various industries in the design and engineering space, from the building, civil, energy, process, plant, and manufacturing. So that's a little insight into Baker Baines for the guys that have not heard of us before. I'm going to introduce you to my colleague now, Heilandi Burger, who is the process plant specialist and manufacturing specialist, technical specialist at Baker Baines. As you can see, Heilandi Burger is quite passionate about the design side of it as well as manufacturing. She has a mechanical engineering diploma. She's served industry-wise with over 10 years experience in the drawing office. She's passionate about data management as well as music, and she is a bass guitarist. So without further ado, I'm going to welcome Heilandi Burger, who's going to give us some great insight into the presentation today. So thank you very much.
Thanks, Daneel. A few of our customers told me in the last few months they wish that we could meet in person and have a wine and dine like you used to in the past. And yeah, that would have been nice, but this is at least an alternative where we can still meet and we can still discuss the future with technology. So First of all, I'm going to start off with a poll question, please. How familiar are you with Baker Baines and all of our offerings? I'm going to give about a minute. Just answer for me. You're not familiar with us at all. You're somewhat familiar, or you've been a client for years and you know everything about Baker Baines and what we've got to offer.
I think we'll give the poll 10 more seconds before we close it off.
Thanks, Daneel. Okay, so the Industrial Revolution. I'm going to share a little bit of the history and what is happening with it. So there's actually four, or there were and are, because today we are in the fourth Industrial Revolution, number 1, 2, and 3. In the first Industrial Revolution, you had mechanization, water power, steam, and steam power. Mass production was the second revolution with assembly lines and electricity that came to light. Computer and automation was part of the third Industrial Revolution, and now we are in the cyber physical systems. So before the first Industrial Revolution, most of the industrial work was done manually or aided with animals. The first Industrial Revolution was started in the 18th century. During this, manual tasks were replaced by use of steam engines and other machines. Agriculture and textile industry benefit the most from the first Industrial Revolution. The second Industrial Revolution was started with the use of steel and electricity inside factories. It started at the end of the 19th century and the early days of the 20th century. During this era, factories were electrified. As a result, productivity increased and mass manufacturing concepts also came into the picture. Development of railway networks also enabled the transportation of goods from one place to another faster. So, and now we are living in the era of the fourth Industrial Revolution, or Industry 4.0. In advanced factories, automated machines and robots are aiding human workforce to do manufacturing activities. But this is just the start. Industry 4.0 will take manufacturing to a new level by introducing the concept of smart factories, producing smart products using flexible mass manufacturing technologies. Inside smart, fully automated factories, machines will operate independently. So how does Industry 4.0 work? Cyber physical systems are a key for Industry 4.0. Smart factories utilizes the Internet of Things to connect smart machines, material, and processes to the Internet. These machines and real-time data to the cloud. In the cloud, this data is processed using machine learning algorithms. Processed data is sent back to the smart machine, where a modern control system controls the machines and robots to manufacture parts automatically. In this way, high productivity can be achieved without having any of the impact on product quality. The ultimate goal of smart factories or Industry 4.0 is to manufacture products without human intervention. So the World Economic Forum estimated that by 2020, more than 50 billion things, ranging from cranes to coffee machines, will be connected to the Internet. Now, 2020 was last year already. Just think about it. 50 billion things are connected to the Internet. So products become assets that can be connected to the Internet, which means they can be remotely monitored. This can help companies to better understand how assets are used, to predict when they need maintenance, and to sharpen the total cost of ownership models. By knowing what faults can be avoided or their impact minimized, and with a better understanding of risk and financial exposure, companies can establish service-based contracts with service-level agreements based on reliable data.
What will the manufacturing of tomorrow look like? Industrial parts are becoming smaller. Products get to market with less waste, faster, and on time. Even the most manual processes are turning towards automation. Innovations in machine vision, deep learning, and robotics are revolutionizing production lines and supply chains. Our machines now produce vast amounts of big data accessible via the cloud. As machines and the information they produce become linked, new cyber-physical systems will spark a modern-day industrial revolution. This is Industry 4.0. In Industry 4.0, smart machines learn from their environments and take corrective actions to optimize production. These machines work independently of a central controller, collaborating and communicating with other devices. Industry 4.0 factories produce new organizational intelligence, which spreads across facilities and is accessible anywhere. The result, nothing short of total transformation of production lines and business performance. Machine vision will be at the heart of this new manufacturing paradigm.
So Industry 4.0 signifies the promise of a new industrial revolution, one that marries advanced production and operations techniques with smart digital technology to create a digital enterprise that would not only be interconnected and autonomous, but could communicate, analyze, and use data to drive further intelligence back in the physical world. It represents the ways in which smart connected technology would become embedded within organizations, people, and assets, and is marked by the emergence of capabilities such as robotics, analytics, artificial intelligence, and cognitive technologies, nanotechnology, quantum computing, wearables, the Internet of Things, additive manufacturing, and advanced materials. While its roots are in manufacturing, Industry 4.0 is about more than simply production. Smart connected technologies can transform how parts and products are designed, made, used, and maintained. They can also transform organizations themselves, how they make sense of information and act upon it to achieve operational excellence, and continually improve the consumer or partner experience. In short, Industry 4.0 is ushering in a digital reality that may alter the rules of production, operations, workforce, and even society. The following technologies that are driving forth the fourth industrial revolution are the integration of software from mechanical and hardware technologies, autonomous robots and smart machines, industrial Internet of Things, data analysis, artificial intelligence and machine learning, big data, cloud computing, additive manufacturing technologies, real-time simulation and product design, digital twin, and data visualization. So we at Baker Baines we've done a lot of thinking, and we've decided that there's a few steps that we believe our clients actually need to take to get to Industry 4.0. So for the design for Industry 4.0, the top steps that we believe in and that we are going to address in the next few months and already addressed, like the 2D to 3D, are also design automation, GD&T, simulation and design automation, generative design, documentation and visualization, advanced manufacturing, maintain and control, and data management. Data management will always be part of any of the steps that you take to become better as a company. And we will keep that underlying in every webinar that we have and every event we've got. We will keep talking about it because it's really, really, really very important to all of us. So the 4 steps we're going to introduce for the next few months, 2D to 3D, as already discussed, design automation, simulation, generative design, and then the foundation, data management. We already started with changing, updating, or redesigning your 2D to 3D designs, and we will talk about this a bit later with one of our customers who are currently going through this process. So data management, from step 1 until infinity. Why do we need this? Well, because this is the problem we've all built. Data is all over, in different departments, in different file formats that get sent around. How many emails do you get in a day? And how many of them have an attachment? Something that you have to go in and look at. Every company is like this, with processes that need to be improved. This is what we are finding. The flow of information never stops, and there's always data somewhere. Data takes different forms. Sometimes it's a file, sometimes it transcends a file and is something else. When you have a design in a variety of CAD applications, there's only really one good place for it, and that is a PDM system. At Autodesk, we call that Vault. Vault data management comes with a variety of different Autodesk products, like Inventor Standalone and the Product Design and Manufacturing Collection. If you use these tools, you already have Vault Basic. There are other flavors of Vault, such as Vault Professional, and we'll discuss it a bit later. Vault is there, it centralizes your data, and it is the place to find up-to-date information. In short, if it's not in Vault, what are you even doing with it? Where are you saving it? Given the current situation, Vault is meant to be behind your firewall. It's a domain. It's usually on site because that's where the server is. Even if it's virtualized, that's where the server is. That's where the backups occur. It's where everything is. But just because we're working remotely, working from home nowadays, it doesn't have to stop. You don't have to go and scatter and everyone do their own things all over the show. There's a way to stay connected to your data and each other. And of course, no company will be able to perform optimally if their data management is a mess. With Vault, we can rectify that. You can just look at this short video.
Sometimes it's not the project holding you back, it's everything else. It's searching through disorganized files. It's opening a file only to find it's been overwritten by someone else. It's chasing down signatures or change orders. Working with cumbersome spreadsheets. Designing takes a lot of work that has nothing to do with designing. So how can we cut through the chaos and get back to the real work? Vault is a product data management solution designed just for engineers. It directly integrates with your CAD environment, so you can find what you need quickly, access and configure files easily, and prevent scrap and rework. But it's more than CAD file management. It allows you to share views with others. It streamlines communication, versioning, and organization. In short, it equips engineers to work and collaborate more efficiently, which helps you deliver better products faster and at lower cost.
So Autodesk Vault has a product family. It's a stack of products, and each offering has incremental functionality over the previous product. While the Autodesk Vault Basic is included with many Autodesk design applications, additional functionality is available based on your needs. The following products are part of the Autodesk Vault family. You can have Vault Basic. So with Vault Basic, you can do the basic file management. You have a single workgroup. You have fast searching, Autodesk CAD integrations, and design reuse tools. With the Vault workgroup, you will have file revision control and lifecycles, utilities for batch plotting, automatic file naming, standalone client for non-CAD users, file and folder security, reporting, and server-based DWF publishing. Now with Vault Professional, you will get all the functionality of Vault Basic plus Vault Workgroup. And also, on top of that, custom objects, multi-site replication, search, view, and print web client, advanced backup and Windows authentication, bill of materials management, engineering change management, and it coexists with enterprise business systems. So just a reminder, Vault comes in about 40 different applications. That means that in Canvas, we can check in, check out, log in, log out, undo checkout, and with some of the other tools and with Vault Professional, we can actually change the lifecycle states, categorize, run reports, on a vaulted item right from inside the CAD tool. So it runs inside of CAD. It also has a plugin for Office. So if you have Microsoft Word, Excel, PowerPoint, even Outlook. Outlook has a Vault plugin where you can take your email and your correspondence, check it into Vault, and have it as part of your project part. And it stays part of the job. We even have plugins for other products like SolidWorks, Creo, and MicroStation. All this means is that Vault is there as your central go-to place for all of your data. So we're going to talk a little bit about the 2D to 3D designs that we believe is now step one. It may not always sound as simple as just changing your 2D to 3D design. And like a magic wand, overnight, everything is done. Unfortunately, we do not have Cinderella's mice and or the fairy godmother to help with that. But with the interoperability between Inventor and AutoCAD, it surely makes things a lot easier. The products mentioned above are everything you need to get this done. At the heart of our products are the PDM collection. As you can see, it has a whole lot of other software built into it. For step one, you might just need AutoCAD and Inventor. But as you progress in your journey to Industry 4.0, you will need more and more of the products in the PDM collection. So a lot of the engineering companies have these barriers, these issues that they don't want to actually address. I'm just quickly going to speak about a few of them. So barrier number one, you might say, we won't migrate. We don't want to redo. We do not want to lose all our legacy data. So your legacy data is safe with 3D. Associative connections allow you to use data across 2D and 3D platforms, no matter what tool originally created it. Take a case-by-case approach. To pick the best tool for the job at hand, here are a couple approaches to consider. Keep it in 2D. It's flexible and fast for minor changes and conceptual designs. Or bring it into 3D. Generate models from your 2D data for automated workflows and easier editing. 3D is also useful for applications like design validations, rendering, configuration, and NC toolpaths. Now, 2D and 3D CAD work better together. Adding 3D helps you improve efficiency and get more from your design with features like the simplest part that has something to gain from 3D CAD. Besides, even if 2D CAD seems like a faster and easier option up front, the output is still a 2D drawing that doesn't contain all the information needed to actually develop a 3D product, nor does it really meet downstream needs. Now, partnering both tools maximizes productivity across the development process. The cost of 3D CAD will be returned over and over again. Since 2D and 3D work together, you can adopt 3D at your own pace without missing a beat. No need to worry about downtime due to migration or flipping a switch from one to the other. Advanced simulation, automated modeling workflows, high-quality visualizations, CAM integrations are just a few of the benefits of having it in 3D. So barrier number 3, people can say simple designs don't require 3D software. Even the simplest part has something to gain from 3D CAD. Besides, even if 2D CAD seems like the faster and easier option up front, the output is still developed. You don't actually need the 3D product. That's what you might say. But downstream, when you're partnering both tools, your productivity will increase, the development process will be quicker, and the output to the client will be just so much better. Barrier number 4, implementing new 3D CAD software will slow us down. Well, since 2D and 3D work together, you can adopt 3D at your own pace, like I've mentioned before, without missing a beat. You don't need to worry about downtime due to migration or flipping the switch from one to the other, because they are adaptable. Number 5, isn't 3D CAD expensive? The cost of 3D CAD will be returned over and over again. These efficiency gains, reduced waste, improvement of product quality, and the value that you offer to your customers. In the next video, you will see how a part that's drawn in 2D is used to update an assembly in Inventor to 3D.
For years, designers have been taking advantage of the layout capabilities of 2D tools such as AutoCAD. Here we see a fairly standard 3D orthographic drawing layout. Autodesk Product Design Suite extends the usefulness of these drawings by allowing users to import selected elements directly into Inventor sketches and leverage existing 2D documentation, thus simplifying the creation of the 3D design. To utilize this 2D AutoCAD drawing in the Inventor sketch environment, select the ACAD command from the Insert commands on the Sketch tab. From the Open dialog box, select the AutoCAD file to use as an Inventor sketch. This opens the Layers and Objects Import Options dialog box, where you will select specific entities that will be used as sketch geometry. From here, layers may be enabled and disabled, and options regarding the configuration of those entities to be placed in the Inventor sketch, such as default units, disposition of constraints, and blocks, are set. After this geometry is placed on the active sketch plane, it may need to be positioned relative to the current sketch origin, depending on values contained in the original AutoCAD drawing. From this point forward, this sketch geometry will behave like all other sketch geometry. Regions within the sketch may be selected and used for extrusions, revolves, etc. Inventor's new mini toolbar facilitates the setting of properties for this new extrusion feature. In this example, multi-body part modeling techniques are employed to facilitate the design of a weldment assembly within a single part, utilizing a single sketch.
Okay, so next up, we're going to discuss a little bit of design automation. So design automation enables you to capture and reuse engineering knowledge and intent. Automation not only helps reduce errors and time spent on tedious, repetitive modeling tasks, but it can also be scaled to streamline downstream development processes. Design automation can mature from automating basic parameters to full-scale product configuration. Setup can be as simple or as complex as your current needs demand. We can show you how Ilogic technology found in Autodesk Inventor enables engineers to easily utilize rule-based design without complex coding. Sheet metal parts and welded frames often include standard features that require simple yet tedious modeling. Eliminate busy work by automating the creation of typical product features. Manually modifying models to meet customer specs can drain engineering resources. Define parameters to create your 3D model and easily set rules to drive a custom product configurator. Extend your automation beyond engineering with simple-to-code tools that capture and execute standard processes for the creation of drawings, toolpaths, and other documentation. Let's look at how design automation saves you time and give you back the reason for becoming a designer in the first place.
What was it that inspired you to become an engineer? Was it solving complex problems or bringing new designs to life? Now compare that to how you actually spend most of your time. How do we deal with all those routine tasks that interrupt us when they too must get done? Your factory floor uses automation. Why not bring a little bit of that into the engineering offices? With Ilogic technology, design automation saves you time by reusing engineering knowledge and intent within your CAD software. We created Ilogic technology for use inside Autodesk Inventor. There are no expensive third-party add-ons. It's all included. Using parameters that you've defined in your model and a vast library of code snippets, you can create rules intuitively so that next time you need a design generated, just input the parameters and the work is done for you. It's that simple.
To model an impeller manually took a couple of days previously. With the Ilogic program, it takes about 15 minutes. If we're modeling hundreds of impellers a year, to create this program is absolutely worth it.
Inventor automation technology is versatile enough to address your specific processes and ultimately free up your time to focus on creating what's next. Design automation with Ilogic. It's all within Autodesk Inventor.
Okay, we're almost at the end of our industry journey. The simulation. Manufacturing simulation is the computer-based modeling of a real production system. Simulation allows organizations in the manufacturing industry to analyze and experiment with their processes in a virtual setting, reducing the time and cost requirements associated with physical testing. Unsurprisingly then, running a high-functioning production line can be quite a challenge. Businesses are constantly adjusting their manufacturing schedules to fulfill ambitious quality, cost, delivery, and flexible goals. The wrong move can result in major supply chain disruption. So it's essential to have the right support. So with simulation, it will help you to get shorter production cycles, faster data entry times, alleviate work in progress, reduces lead times. There's more customer satisfaction, accurate sequence planning, better quality products, fewer admin tasks, and empowered leaders. Picking the right manufacturing process software is key. So Autodesk Inventor Simulation Suite software combines a simulator for motion dynamics with a powerful linear finite element stress analysis application. To understand the performance of a proposed design, a designer starts by running the dynamic simulation tool to calculate the dynamic performance. The result of the simulation represents the positions, velocities, and accelerations of the mechanism throughout its operation cycle. It also includes the reaction forces at each joint. These forces are then used as the input parameters for the second phase, in which finite element stress analysis is used to compute and internal stresses in those highly loaded parts. This process is summarized in an accompanying diagram. So I'm just going to quickly run through the diagram with you. You've got the Inventor assembly. Convert the constraints to joints. Add springs to the contact sets as required. Add environmental constraints and run the dynamic simulator. Then analyze the results. Now you have to ask the question, does the design work? If no, then you will have to modify. After you've done your modifications, you will go all the way back to run the dynamic simulator again. Analyze the results and ask yourself now, does this design work? If yes, you move to the FEA phase. So with the dynamic simulation phase complete, you will transfer your reaction loads to FEA. You will run a FEA analysis, analyze the results, and ask the question, is stress within the limits? If no, you need to modify and go all the way back to run the dynamic simulator again and start the process downward. It sounds a little bit tedious, but once you get used to it, it is actually going very fast and very quickly. And by the end, you ask yourself the question again, is stress within the limits? And it's yes, your analysis is complete and you know that you've got a quality product. So Autodesk Inventor Simulation Suite addresses the shortcomings of traditional, dedicated FEA and motion analysis solutions by providing easy-to-use tools that work directly with Inventor 3D model. The resulting ease of use gives designers a true digital prototype that can be used to experiment with different design options. At the same time, it can increase confidence that the performance of the final design will meet the customer's expectations. The ability to predict and transfer reaction forces to the stress analysis environment allows designers to leverage the digital prototype to optimize part geometry while reducing the need to build costly physical prototypes. So simulation has become an essential tool that every engineer can now use. That is because when you use simulation, you can evaluate decisions as you make them, create more opportunity, like improve performance and reduce the likelihood of failure. With the PDM collection, you have access to a wide range of simulation tools, including nonlinear, thermal, fatigue, vibration, analysis, right inside of your software. Linear analysis is helpful, as often included, but it is limited to static loads and a material model that is only appropriate for metal. On the other hand, nonlinear studies eliminate several limitations. They provide advanced material models specific for plastic, rubber, or foam. Choosing the appropriate material is essential to determine accurate results. Determining the stress and deflection gives insight to design integrity, but does not tell the entire story. Is it possible that your design may buckle at some point as the load is applied? This can only be checked by running a linear or non-linear buckling study type. And if there's issues, it can be made based on the results from the solution. And remember, the study types you have set up can simply be run again. The moment your model has been updated, all in one interface, the tools included in the PDM collection help you to gain valuable feedback in your design decisions early in the process, giving you more opportunities to reduce cost and validate performance. The fourth step that we would like to discuss with you is one that a lot of people find very exciting, but are also a bit scared of because they don't really know what the extent of this tool is. It's generative design. It's an interactive design process that involves a program that will generate a certain number of outputs that meet certain constraints, and a designer that will fine-tune the feasible region by selecting specific outputs or changing input values, ranges, and distribution. The designer doesn't need to be a human. It can be a test program in a testing environment or an artificial intelligence. For example, a generative adversarial network. The designer learns to refine the program, usually involving algorithms. With each iteration, as their design goals become better defined over time. Now, Autodesk Inventor is a great tool for most types of mechanical design. However, sometimes you need a creative spark to come up with an innovative solution with a significantly different shape, characteristics, or weight. In this case, generative design technology can be used as a part of your existing workflow and inspire ideas that are difficult or even impossible to get otherwise. Using artificial intelligence software and the computing power of the cloud, generative design enables engineers to create thousands of design options by simply defining their design problem with basic parameters such as height, weight, what it must support, strength, and material options. As with any new technology, however, there's often confusion and a lack of clarity around what exactly the technology is and what it isn't. Engineering teams are constantly under pressure to get products to market in less time. I'm going to show you now, once again, a little video of what generative design is and how it can help you to make your life better. So the pressure to get the products to market in less time are limiting the ability of the engineers. Using the PDM collection, in addition to your traditional design tools like Inventor, can help you develop better products and elevate your business without adding an innovation lab to your department. Generative design in Fusion 360 is a new way to solve engineering challenges in more efficient ways. With Fusion 360 and Inventor, both being part of the PDM collection, you have traditional CAD tools, but you are also able to explore the power of cloud computing, keeping down the price of expensive computer equipment by speeding up the processing time. This can help your engineers choose the best design from multiple pre-validated concept models faster with less cost. Generative design in Fusion 360 is a technology that generates design alternatives. Design engineers input goals along with parameters such as performance or materials and manufacturing methods. The software provides multiple outcomes, pre-validated against loads, constraints, materials, and manufacturing processes. Engineers are no longer limited by their imagination or their training or their previous experience, but they are empowered to make trade-off decisions for materials, cost, and manufacturing methods. All of this happens in less time than your team can currently develop and evaluate one or two alternatives. Gain a competitive advantage with Inventor and generative design as part of the PDM collection. Empower your team to optimize and deliver on high-performing design alternatives that traditionally design development couldn't provide. So we've got a poll question, and we would like to know, which one of the 4 steps in the Industry 4.0 do you think you fall under? Will it be 2D to 3D design, simulation, automation, or generative design?
See, the answers are coming in quite nicely. I will just give it a couple of more seconds before we close the poll.
Thanks, Daneel.
Okay, I think it's safe to close the poll. I'm going to share the results with you now. Interesting results there, Heilandi.
Yes, Daneel.
Okay, back to you.
Thanks. Okay, so how can we help you? Five famous words of Baker Banks. So, do you want to kickstart your journey with either maybe Vault for your data management or Fusion 360 to start with generative design? So we offer a range of Kickstarters to get you going with your new products. And we can assist with the basics. So are you interested in document management per se? So we can do assessments for you to evaluate your document management system and suggest alternatives. We can sit with you, we can work through your processes, and we can see what will be the best solution for you. So are you already on your way to Industry 4.0 and you just need a little bit more help? Maybe you already are at the advanced 2D to 3D stage and you started automating already, but you need that little extra. We have specialist series in Vault and Inventor for the manufacturing side, but there's a range of products that we actually do have specialist series for. You can just contact us at any time. So if you would like to take that step further, then remember, the specialist series is for you. So I adopt, as Daneel did discuss earlier in the presentation with you guys, are our unique way of assessing your company to see at what point you are in this process. We will educate you on the topics that you are not so familiar with, and we will proceed with expert advice to help you, or rather guide you to get to Industry 4.0. So your company shouldn't be left behind, but that you can be the one that's in the forefront, leading the way, standing out from the rest. So what is iAdopt? iAdopt is our unique consulting methodology that we do to help you. So we develop and implement a digital strategy and transformation system with you. We optimize your business processes and your workflows. We help you to adopt technology, and we help you to design and make a better world. The benefits of this is that it focuses on solving your problem. We deliver tangible outcomes. It's an holistic addressing of your organizational issues. And we go beyond the CAD environment, and it includes change management. So at this point, we have our customer spotlight, which is Mike from Debmar. I'm going to hand over to Daneel for the introduction.
I'm sure everyone online would agree with me that we've learned something very insightful from your presentation and to getting us to Industry 4.0. So thank you for that. So I'm quite glad and quite honored today to have a company called Debmar Manufacturing out in KZN join us on this presentation today. We've got Mike Kovacic that's going to be speaking on behalf of Debmar, and I think he's got some really insightful bits to add to us to show us how they've actually moved forward and getting to the right steps for designing for Industry 4.0. So without further ado, I'm going to introduce Mike. Mike, welcome, and thank you for joining us today.
Okay. Sorry, I'm a little problem here.
Mike.
Okay. Sorry about that. As Daneel has introduced me, my name is Mike. I run the drawing office here at Debmar. I've been here just under a year since Debmar made the decision to convert completely from 2D to 3D. And I'm excited at the challenge of modeling all the old AutoCAD 2D drawings and old paper drawings into Inventor 3D. Debmar Manufacturing Company is an established manufacturer of screening machines and has been in the bulk materials handling and processing space for about 55 years. Our factory is located in Hattingspreit, KZN, but we do have a global reach with our equipment having been installed in over 16 countries. We design, build, test and manufacture our screens and products in-house and are proud of the fact that the vast majority of our screen components are manufactured right here in Hattingspreit. We still have our original drawing office and drawing boards at Debmar. Debmar began its exploration into 2D CAD in the early 80s, late 80s, early 90s. We immediately saw the value and advantages of a computer-based system. As technology developed globally, we dived in where possible. When 3D drafting became practical and accessible for the consumer market, we once again saw the advantages of being able to draft our products in that environment. The ability to be able to interact with your products in a virtual 3D world means we can accurately design and develop new ideas and modifications in a fraction of the time. What is 2D? 2D, as most of you will know, is two-dimensional drawing. The drawing is only done using two axes, the X and the Y axes. Every single entity drawn has coordinates in the X and Y axis only. The Z coordinate is always 0. It is literally like drawing on a flat piece of paper. You cannot rotate it around multiple axes like you can in 3D. You can only rotate it about the Z axis. Think about your flat piece of paper on a flat table, the front edge of the table being your X axis and the side edge being the Y axis, and the surface of the table being your XY plane, where the Z axis is perpendicular to it and always equals 0 on the table surface. You can only rotate your flat piece of paper on the surface of the table. What is 3D? 3D is three-dimensional drawing. This is really no longer called drawing as such. It is called modeling, and is done using all three axes, the x-axis, the y-axis, and the z-axis. Every single entity modeled has coordinates in all three of those axes, x, y, and z. We are modeling in 3D space, and you can rotate your model around the x, y, or z axis, or any one of another infinite number of user-defined axes. Your flat piece of paper can be now thought of as the plane, any plane you choose, that the view you want of the 3D model is projected onto. Advantages of 2D over 3D. Once you have finished modeling your object, you can automatically project any view you want and automatically either show it with or without hidden lines. You don't have to draw and work out how each and every view looks like you do in 2D. Not only can you generate any view you want, you can generate any section through any part of your object. You can generate any 3D view you want from any angle, either an orthographic projection, parallel sides, or perspective projection, sides joining up at a single point far in the distance. Once you have finished the model, you can automatically generate the mass as long as the correct material properties, i.e. density, are current for that model. Once the model is complete, you can send it to a 3D printer to have a look and feel what it's actually going to be like in reality once it is manufactured. Once the model is complete, you can do a stress analysis on it to see where it might fail and where the most highly stressed areas are going to be. The factory personnel using the drawings to do the manufacturing will understand the drawings are a whole lot better with the additional 3D views, and this has already proved to be the case with the new 3D drawings we have issued. Far better understanding of the drawing, less grey areas, less chances of mistakes, and far less questions back to the drawing office. And then also clash analysis, where all clashes will be highlighted in a different color. None of these are possible in 2D. You can have Teams meetings with potential customers or existing clients to show them the 3D model of their machine by sharing your screen with them, and you can visually see, measure, discuss, and come to conclusions, as was recently done with engineers from one of our existing customers in Yorkshire, UK. And there's an example of one of our 3D models that we used to discuss with them. You can generate parts books for customers to order quickly and accurately any spares he might need. The parts book will give the name of the customer, machine model, and serial number. It gives a 3D view of the complete machine and then separate 3D views of each different set of main sub-assemblies, along with a label, which is a reference to a list giving the name and part number of the specific item. Many customers ask for these posters as they are easy to use to identify, order, and talk about parts. And there's an example of one of our illustrated parts catalogs for one of our customers. And here's an example of the sub-assemblies with the parts there, and makes it very easy for the customer to see what's in his machine and what to order. You can generate parts posters for customer quick reference, as we have done for a lot of our customers. Here is a poster we did for one of our customers, labeling all the major parts with their generic names for use in discussion. And that poster is a lot easier to use in a parts book if you just in a general discussion with a customer. You can even do videos from exploded assemblies to show how the machine goes together, or even how specific important sub-assemblies go together, using the Inventor IPN function, which allows you to export to video format. Vault data management advantages. Vault enables you to check into a central cloud or local-based database on a regular basis, so that all the drawings and relevant info is easily accessible to all involved, wherever they might be physically located. Vault is a very secure, and the administrator can set permissions as to who can access and in what cases where certain people only need to see certain information or drawings. The version history enables you to keep track of exactly what each person has done to each drawing, and also enables you to revert back to old versions whenever required. Vault, with the strict rules and the ability for you to set certain rules, forces you to be very structured and very tidy in the way you save, file, retrieve, and share your drawings and info. And
okay, Mike, thank you for that great insight into DevMA and how you do it. But I just have a couple of questions. So with regards to your transition from 2D to 3D, I know you mentioned that you got there were quite a bit of 2D work and there was some small transitions being made. However, looking at it, how has that impacted DevMA itself with the time saving, or has there been any time saving with that?
Yes, definitely. Talking to the factory staff and supervisors, they say that it is now so much easier to read and interpret the drawing with the extra accurate views generated from the model, as well as the 3D views themselves, that the manufacturing time is actually now faster and there is less chance of mistakes, and also a lot fewer queries coming back to the drawing office.
That's interesting. That's nice insight. And also, how did what impact did it have on your customers presenting back, machines that were requested for design, manufacture, or just illustrations of it, as you shown earlier on?
Yes, the posters have been extremely useful to us and our customers, as it helps them to quickly and easily identify parts, and also allows familiarity with the parts and allows the customers to order the parts quickly. Many customers find this a lot easier than using a parts book, as the whole screen is shown in the one image. So the posters, in addition to the parts books, are actually quite popular.
Okay, so those are some good benefits that you've seen moving across. And I'm sure with having a workflow set up where you're using document management to manage that data must have been quite a nice change than just having it saved on a server somewhere.
Yes, definitely. A lot of the benefits we've seen, as I've already mentioned, is a far better understanding and interpretation and visualization of the drawings by the manufacturing staff that are using them. We've also been able to use the 3D models in PDF format to enter into our material resources planning system, which is called SEP, and it's much clearer than actually using photographs, and enables the SEP users themselves to easily identify the parts. And we have also been able to compile parts catalog and posters, which I've already mentioned on my presentation, which have enabled our customers and potential customers to far better see what is on offer and what they are getting. And this is often a game changer compared to a verbal explanation with a 2D drawing. So,
Mike, so thank you very much, and thank you for that great insight into 2D to 3D, as well as data management and how it's affected or changed, great change at DevMA. So thank you for that information, and we wish you all the best moving forward with regards to your journey to Industry 4.0.
Thanks very much for having me.
Thank you. So moving along, I'm going to take you through the key takeaways from today's session. And I believe that, the great information that was shared by Heilandi is also some of the nice insights from Mike on how DevMA is doing stuff and how they're evolving into it would resonate with everyone on the call. I think the first thing for me is to understand how to become proficient with the prerequisite of designing for Industry 4.0, because as we've seen on the poll result, we've noticed that, sorry, I think somebody's there. Sorry, guys. I just want to get back to that. Sorry, thank you for that. So I think just understanding the way that the way forward, we've noticed that also from the poll results, lots of people are still on 2D and 3D and still want to move forward. So understanding that is great. Data management is quite a big thing, and Heilandi's quite nicely, as well as Mike earlier on, because everything that we starts with data. So every design that starts with data, and that data is managed correctly, it allows us to be more productive downstream of that data and how to, in various other aspects. It could be simulation, generative design, or just understanding a better 3D model, as Mike mentioned earlier on. And I think understanding how we can help you to get to that is key, because as Heilandi mentioned earlier on, we've offered various different options or different services that can get you there. And seeing from the results, 2D to 3D has been the greatest percentage feedback on. There's a great step to start to move you forward. So these are the key takeaways for me. We're going to open up into questions now. You can go in and use the chat box for questions to highlight anything that you may want to ask, or any questions that you may have. So I'm going to open up the chat box, your messages on the chat box, and we'll get answering. There has been a question come up here from Peter. So I'm going to read the question out. Heilandi, I think this one's for you. I think it came in as soon as you were doing your presentation. Is Ilogic only available in Inventor, or can it be used in AutoCAD? So over to you on that one, Heilandi.
Ilogic is only available in Inventor. But it's very easy to take your 2D designs in AutoCAD and move it over to Inventor, and then from there address the Ilogic issues that you have. Okay, excellent. And while we're on the Ilogic, you don't have to be a programmer or somebody that has any development background. I'm sure it's quite easy to use. I believe there's something called snippets that help you move along that. Is that correct? Yes, it's very easy to use. Very user-friendly, and we do offer training, as I mentioned earlier, for the more advanced people on the Ilogic, and that is very quick. I think it's a half-day course even, and then it will set you on your way to be able to use the Ilogic the compatibilities that Inventor has. Okay, so I see another question come up here that speaks about 2D to 3D and generative design. So how difficult it is to get to that point from, when you're proficient in 3D modeling from 2D to getting to generative design? Is it quite a drastic step, or how would you describe that, Heilandi? Well, it will depend from company to company. At the previous company I worked at, we started by taking our panels. We designed a substation, automation, and protection panels. And at first, it used to be an issue with the workshop, never placing the components where they're supposed to. So we started by designing only the panels in 3D, so that the workshop can see in real life what it's supposed to look like. And we could see what is actually now in the way of something else, what is constricting something else to be placed at that specific point. We didn't go into depth yet by the time that I moved from the company, but we would have loved to integrate AutoCAD electrical with Inventor to even get the wire lengths that you can. So it will definitely differ from company to company. Some of the companies that I've spoken with in the last 3 to 6 months, they actually said that they are getting one particular person to do only that, because they don't have the time to have their normal designers spend on converting, but they know what the benefit is. So I don't really think that it is very difficult to do, because as we've seen, it's easy to take your CAD into Inventor and use it in Inventor and fix it, but it will definitely depend on company to company and person to person. Wow, that's interesting. Thank you for that, Heilandi. So I see another question here on how to present the model for the client using video. So this was from Delani. So I think, Mike, do you have any insight on that, on getting your models to videos?
Yes, in Inventor, once you've drawn your model, you can turn it into an IPN drawing, and then you can start exploding it in different orders, and then you can create from the IPN function, you can actually create it in video format, and then you can show it to your customer. So that is very possible in Inventor. There is a special function to do that in Inventor, and it is very useful. Okay, nice. And I'm sure once you've got an exploded model of that design, you can take that to drawings as well, if I'm correct? Yes, you can convert your IPN into an IDW and have it in a drawing format as well, which is also very nice as well. You can see the inside and how it's exploded and everything, so that's very useful as well.
More or less for a parts manual, right?
For a parts manual in particular, that is very useful, yes.
Okay, all right, thank you for that. Does 3D modeling detail maintenance requirements for future cost of ownership? Heilandi, do you have any insight on that one? Heilandi, sorry, I think the mute was on there.
Okay, sorry, no, I also didn't get your whole question. There was some point where you just faded away.
So this question from Lewis that asks, does 3D modeling detail maintenance requirements for future cost of ownership? So I think what Lewis is trying to get here is maybe detailing perhaps maintenance that could come up once that machine is produced and it's out in production. Would there be any benefit of having 3D models on that, or how would you see that?
Yeah, no, definitely. There will definitely be. I mean, in 2D, you will not necessarily see all the components and equipment that is making up that specific part. So in 3D, you will definitely see all the different components. And when you go that little step further into simulation and your automation, basically, then you will get the reports back to say that, listen up, there is a problem, you need to tend to it. So no, definitely, 3D, I think, is definitely going to help with maintenance in the future.
Okay, wonderful. And there's another question that's come up on the screen here that says, is it compatible with Creo Parametric? Now, this is from Bambela. Bambela, I'm not sure if it's directed to the data management vault or Inventor, but I think I'll take a shot at this one, right? So if it's data management, yes, Autodesk Vault Professional has an add-in for other parametric tools like Creo, for example, Solidworks. If you're talking about the design, sharing your design from your 3D model from Creo to Inventor, definitely has an any CAD function, which allows you to import different CAD file formats into Inventor for documentation, use in assemblies, as well as a bit of modification based off the metadata. So there's certain metadata that will come in from there. Okay, thank you for that. Any other questions? Okay, which data management software is compatible with Solidworks? That's from Ellen. So Heilandi, I'll hand that one over to you.
Okay, so Solidworks is also compatible with Vault. There's a plugin that you can get. So yeah, basically Vault can handle your Solidworks drawings.
Okay.
Know that there's also docs, Autodesk docs, more the other side of our company, and I'm sure that will also be compatible with Solidworks.
Sure. Okay, so I think that answers the question. I know from past customers speaking, a lot of the Solidworks customers use Vault as the data management tool, just so comprehensive for data and document management, as well as it's not that complicated to set up. So, so the answer to that is yes, it's definitely compatible. All right. Do we have any more questions? Okay, I think we'll call it there. Again, thank you for joining. If you want to get in touch with us, these are our contact details on screen. Not sure why it's not showing. Okay, thank you, Heilandi. So these are our contact details on screen. You'll find that you can contact us. You can find us on LinkedIn. We've got a social media page for Twitter, Facebook, as well as Instagram. And I think our YouTube channel has grown quite a bit of popularity. So as Heilandi mentioned in the past, while she was doing her session, there has been some webinars that she's done in the past month or so, a couple of months, on 2D to 3D, moving you from 2D to 3D and helping you go there. And I know in future there is going to be more information leading up to the steps of getting you designing to Industry 4.0. So I think look out for them, catch us on the webinars. The next one is going to be very interesting, which is design automation. Am I right, Heilandi? Yeah, I think that's a nod. That's a yes. Okay.
It is a yes. Yes, sorry. It just seemed to be feedback, so I mute myself from time to time. Yeah. No, the next will be design automation, and we're looking very well, we're excited about it, and looking forward to seeing all of you there.
Yeah, good. So I hope everyone online can join us for these webinars. We'll be using this as a series, so you'll find that the steps highlighted by Heilandi earlier on today is going to be covered in each. We look forward to seeing you there. I see there is another question from Delani. Delani, let me get back to you with cost of ownership, if that's okay with you. And yeah, we can pick up conversations from there. So even if you've got questions and they don't come to mind now, please pop us a mail at either info@bakerbains, and we'll be glad to help you out. Okay, thank you very much for attending, and have a great Thursday evening.
Thanks. Bye.